Okay, so let's look at one type of example of modeling with equations. And this one is the money example. So here we have a vending machine and it contains dimes and quarters. And the total value of the dimes and quarters equals $36.85. Okay. And then the dimes and quarters they add up. There's 223 coins in total. The only thing is we don't know how many dimes and how many quarters. We do know that it's only dimes and quarters, and we do know that the value of the dimes and quarters adds up to $36.85. So let's start this equate. Let's start looking at the information and getting an equation. So if you look at this equation here, okay, let's start with that. And we're going to start with our let statements. So let D represent the number of dimes, okay? And let Q represent the number of quarters. Okay, and then it says in total, the dimes and the quarters add up to $36.85. Well, we know dimes are worth 10 cents. So 10 cents is equivalent to 0.1. Okay. And then we know quarters is 0.25. So 25 cents is quarters. Okay. And then this adds up to $36.85. Now, the reason why we do that is because if we know how many dimes there are and we multiply it by zero point 0.1, then we know the value of the dimes. And if we know how many quarters there are and we multiply it by 0.25, then we know the value of quarters. So for your example, if there's 4 quarters, then 4 times 0.25 would be $1. If there was 10 dimes, 10 times zero point 0.1 would be also $1. Okay. But right now we have no idea how many dimes and quarters are. So we're going to leave it like that for now. And then we're going to come to the second statement here where it says there's a total of 223 coins. So that means dimes plus quarters is equal to 223. So if you know how many dimes there are or how many quarters, you can figure out the other value. So we're going to isolate either for D or Q and it doesn't matter. Okay, so we'll say D is equal to 223 minus Q. Or you could do Q is equal to 223 minus D. Either one, it doesn't matter. But now where we see D here, we're going to plug in the 223. So I'm going to go back to this expression here. This is equation 2. Okay, and I'm going to plug in, instead of D, I'm going to write in 223 minus Q. Okay, because that's how many dimes we have. It's 223 coins minus how many quarters we have. That's how many dimes we have. Okay, plus 0.25 Q is equal to 36.85. Okay, so now we got to use our distributive property that we learned in the polynomials unit. So you're going to multiply 223 by 0.1, so 22.3. We're going to multiply it by negative q, so negative 0.1 q, and then 0.25 q is $36.85. All right. Now we're going to bring this here over to this side of the equal sign because it doesn't have the variable q. So everything on the left is going to have a variable q. Everything on the right is not going to have a variable of q. And then I'm going to simplify in a minute. I'm going to do extra steps here just so that you see every little step I do, okay? Okay. Now this turns out to be 0.15 Q, right? So you just go negative zero point 0.1 plus 0.25, which is a 0.15 Q. And then this is, I got to get my calculator, 36.85 minus 22.3, 1455. Okay. And then we want to isolate for Q. So we're going to divide both sides by 0.15, which is the coefficient in front of Q. So we'll find that Q is equal to 97. Okay, so that means there's 97 quarters. Now we want to find how many dimes there are. So D is equal to 223 minus Q, which is this expression up here. Okay, so D is 223 minus 90, oops, I almost wrote another Q, minus 97. So D is equal to 126. Okay, so now we got to finish off this question with a therefore statement. Those are communication marks, right? So therefore, actually, I'm going to do it in purple. I'm going to do all the communication marks in purple here. So therefore, there are 97 dimes. Oh, not 97, sorry. 97 quarters. Sorry about that. And 126 dimes. And there you go. The question is complete. And